In the previous video, I completed the tracks for the excavator, getting it to move. In this episode, I'll be finishing the slewing mechanism, allowing the excavator to rotate. The slewing mechanism of this RC excavator consists of three parts: a ring gear, an inner ring, and an outer ring. The ring gear is embedded into the inner ring via a groove, forming an integrated structure and then secured to the chassis with screws. Both the inner wall of the outer ring and the outer wall of the inner ring have semicircular grooves, which are filled with polyoxymethylene balls. An aluminum plate is then mounted on the outer ring, serving as a support platform for the excavator's other components. I used a CNC router to process the main structures of the inner and outer rings from a 20mm thick polyoxymethylene plastic plate. After removing excess material with a drilling and milling machine, I performed further processing on a lathe. I used a radius grooving tool to machine the concave groove structure on the outer wall of the inner ring. The semicircular concave groove on the inner wall of the outer ring was quite challenging to machine. For this, I used a custom-designed tool holder specifically made for this project, fitted with an RC/M&T round insert. However, polyoxymethylene material deforms significantly before and after processing. When the workpiece was clamped in the lathe chuck, the deformation became even more pronounced, making machining very difficult. The final result was far from ideal, but I had to make do with it. These are 5.55mm diameter polyoxymethylene balls used to fill the grooves between the inner and outer rings. After filling, a small section of polyoxymethylene rod is used to plug the hole and glued in place to prevent the ball bearings from escaping. The internal ring gear of the slewing mechanism was 3D printed. To ensure strength, PLA-CF filament was used. The inner ring of the slewing mechanism is secured to the chassis with 12M3 screws. This aluminum plate is the excavator's slewing platform, which will be fixed to the outer ring of the slewing mechanism with 6M4 screws. However, before that, the slewing drive motor needs to be installed first. A drive gear needs to be installed on the motor shaft. I made it from a small piece of 20mm diameter POM rod. Here I am drilling the M3 tab hole. An M3 set screw will then be used to secure the gear onto the motor shaft. The tapping process is omitted. Let's power it on and test it. The rotation speed of the drive gear seems a bit too fast. After connecting the assisty and the battery, I used the remote control to test it, and the slewing speed was indeed too fast, absolutely unacceptable. Off camera, I replaced it with a slower motor. The replacement process is skipped. This is a 4-input and 4-output conductive slip ring used to connect the ESC and track drive motors. It prevents wires from tangling or knotting during the excavator's slewing motion. However, I later realized I installed it backward here. In my design, these two plastic parts, along with the aluminum plate, form the RC Excavator's slewing platform. The plastic plates are also 3D printed. To install them onto the aluminum plate, hot melt nuts need to be installed in the pre-drilled holes beforehand. The next few parts to be installed were also machined using a CNC router. In future videos, the RC Excavator's boom, hydraulic directional control valve, pressure relief valve, and other components will be installed onto the excavator using these parts. Afterward, the conductive slip ring was reinstalled correctly, and all wires were fitted with JST quit connectors. I also remade a distribution board converting one X-T60 interface to 8 X-T30 interfaces and replaced the motor's ESC with a smaller one. That concludes this episode's content for now. I hope this DIY joy can be conveyed to you, the audience. Thank you all for your continuous support and patient viewing. In the next video, we will bring you the making of the RC Excavator's boom, arm, and bucket. See you next time as we witness our growth and transformation together.